Welcome to a continuation from basics from Hero 0 to Hero section on Python, where we actually started to learn about the basics in Python. The previous session, you realized that we actually talked about how to install Python, some of the basic styles in Python, like introduction. We talked about the comments in Python. We talked about variables. In this instance, we're actually going to talk more about the variables, and we're going to go on to talk about the data types, the numbers, casting, strings, booleans, operators, and all of that that we've not actually covered in the previous video. We're actually going to look at. So, in the previous video, we actually talked about multiple variables where we can actually assign multiple variables. In this instance, where we can assign maybe x equals y equals z, and we can actually assign this here to a value to maybe, let's say, um, 25. All right, so we see now we use multiple variables to actually assign to a specific value in this instance. The same way we can also assign this same multiple variable to a string. Maybe we can have like Samuel. All right, so this is also multiple variables that we've assigned. So this is where we ended on our previous video. So today we're actually going to talk about um, the other parts that we actually did not cover in the previous video. So that is, we're going to talk about data types in Python. So in Python, there are several data types, and all the data types are based on um, whatever value or whatever you're going to use it for. So in Python, data types are important concepts that are actually used to represent different data types or to store different data types. Variables can be used to store different um, data types in different instances. You can use variables to store strings, int, floats, and list and tuple, as well as dictionary and all of that. So we're going to look at all of these data types. So in Python, there are a lot of data types that might not be available in some of the other program languages. So the data types that are available in Python, so data types available in Python. So let's list them here as we can. Let's see. So an easy way to what write multiple lines of code in Python is to state three codes like this, and in here we can write multiple comments in here. So you can also do double quotes, three as such. So here we can write multiple comment here with Python, and that is how you can actually present multiple items. So in here we have strings. Strings is very common with most programming languages, and you might have come across it. And we also have int as well, which also means integer. It's also very common. Um, float, and we have complex. We also have list or tuple or range. Those are all used to represent data. Then we also have dictionary. So dictionary is also available in Python. Then we have sets and frozen sets. We also have bytes. We have byte array. We also have memory view. and we have non-type. This is like some of the stuff that we have in Python that might not be available in most of the programs. So you in several other programming languages you come across string, int, float, complex, but you may have not come across list, tuple, or range. You might not have come across dictionary or set or frozen set, byte, byte array, and you might not have come across some of these data types in other programming languages unique to Python, and that's what makes Python very great. So to be able to get to know about these different data types, so with string, we're talking about stuff like sentence. So it means a string. We actually introduce into bracket like this. There are two quotations like this. It can also be single quotations as we have. It can also be single like this. And seeing that, you can also use it for strings. So in here, you're going to see like sentence. Sentences, words, letters, those are all arrays. These are all strings. Sorry, these are all strings in Python. And for int, we're talking about numbers. And example of some these numbers that in this instance could be numbers that doesn't are literally integers. So numbers that are integers. It means that it may have to be a whole number or numbers that does not have decimals, right? So if you want to represent data or numbers with decimals, you may want to use float. So this could be decimal numbers. Or numbers, for instance, numbers like maybe 5.1 or 50.0. These are examples of numbers that you can actually represent with float. And complex is kind of a bit complex in that instance. This could be numbers, but numbers with floating point as well can also be presented under complex. All right, so this kind of these three actually falls in line with numbers or values in that kind of instance. So this is some of the data types that you would like to use in Python if you want to go with numbers. All right, so we also have list. So list is also one cool data type in Python that we are going to use in a lot of in this example. We're going to use it multiple times that you see how it is, and you're going to see that it's actually very simple to use. So list could come with brackets like this. So it means a list we're talking about something like this. Let me put all of them in different. And so it means you're talking about something like this for list, and for range you are usually talking about um, so let me say maybe ranging between specific numbers and some numbers, right? So those are like different ways of. But let me talk about tuple first. Then probably that will give us an idea on how. So for tuple, we're going to look at data set presented in um, this bracket. So it means it could be, let's say, apple, mango. All right. So the difference between um, tuple and list is that a list actually could represent the same value in here, but in this instance, lists are used to store multiple items on single variable. So you can store multiple items with list, and there are over four built-in data types that falls on the list, or that falls under this kind of category of data. Sorry, that falls on under the like maybe like tuple, list, set. They all kind of follow similar data format, as in like they can all be used. So if you've been on other programming language like maybe Java, you might have come across array, where array kind of you can easily set this kind of data types. But in Python, there are data storage in this category has been put into a lot of phase like list, tuple, set, and so on. So that's what makes them a bit different. So what makes the tuple, just like I said, what makes tuple different, what makes list different is that you can use list to store um, multiple items in a single variable. What you can do with tuple is that you can use tuple to store multiple items as well in um, single variable, but a tuple is a collection which is ordered and unchangeable. It means you can't change any content you put in a tuple. It's ordered and it's unchangeable. It means you can't just change it in and out. But list is created using square bracket, and mostly you can change some parts of list. Alright, so that is what makes list a bit different. And if you talk about sets, sets is also used to store multiple items in single variable. A set is a collection which is unordered, unchangeable, and unindexed. So it means that if you're writing an index, let's say that if let's say I'm talking about sets like this, it means I'm going to say um, it's going to be it's going to use curly bracket like this, and I'm going to have like maybe apple. I'm going to also have maybe mango. Now I can actually index this, so I can't index this is so I can just maybe come here and say maybe to index it like to say to give it like maybe apple is maybe one or something. I can't do that for um, set, but I can actually do that for list in that instance. So that is what makes it a bit different. So it means that it's not actually indexed. It means you can use index to find the data or to be able to pick up details from here. We're going to look into more details into that, into why we say that it's not, so that when you apply it, you're going to see different reasons why. So let's take them one by one, and we're going to look at all of these data types and how they work with Python. So let's start with the strings first, and we can easily go by to. So let's go on strings. So as we said, the strings. So let me bring strings here. So here, for strings. So strings in Python can be, you can just bring this function, this print, and in here we can bring a string. So we can say hello world. So this is in here is a string. We put in these quotations. You can be double quotations or single quotations. So we put this quotation here to show that we want to print a string. And by as soon as we execute this, so we run this, it's going to print out this hello world for us as a string. So if you want to print that, we open. So if you're seeing that you, let me clear this. Want to see you write that, you can just come and say print main.py. Main.py is the file we're actually working on at the moment. So print main.py, and then we can run it and you see that. Okay, so yeah, did not, let me see what. Oh, I wrote print, I'm supposed to write Python. Sorry, Python main.py. So we've seen that when we state print, it actually printed the file name for us. So we have to write Python main.py for it to print out the hello world for us. All right. So this is how example of how we can present string. So we can have multiple of these. We can have this for maybe have multiple of these in different instances. So all right. All right, and we can even have hello world. This is Francis. Francis. Okay. Interactive Python. All right, so you can see that these are all strings, and we can just replicate the same here. You can just run it here, and you can see that it's going to print all of us. Hello, this is Francis on Interactive Python. So that is strings and how strings are represented in Python. So you can also have print string in multiple um, comments. So we can come here and we can say, let's say, um, our sentence. All right, yes, sentence is equal to. So we can do double quotes here, and you know, and within this code, we can actually print an entire text. So let me say this session we are actually discussing interact we're actually discussing data types in Python, and this is for basic section as well as methods. Alright, so this is just something that so with this, it means we've printed, this is a long string or a long sentence in the single, but because of putting quotation, it becomes a string. So this is a multi-line strings where we put in here this three code, just like we did in comment. We can also use this to represent string. So here we can just come in and print sentence. So we can just say print sentence. All right. So if you print sentence, it's actually going to pick this, going to print this for us. So if you come here and here say Python, main.py. So you see that it actually it prints this one for us because we still have this function, this strings here. Now that prints it from there, and also prints this section currently. So it prints this one for us as well. So you're seeing this is you can also use variables within a string just like we do. So that is how string is, and you can see that it's all about sentence. You can also put in numbers. So let's say if you put in this numbers as well, as long as it stays within this code, is also indicated as string. So if you run this once more, you see that it also adds those numbers here, as we can see from down there. All right, so that is how. So any number you put in here becomes a string, and as long as it's in code, it becomes a string. All right, so everything here becomes a string now. All right, yeah. Okay, so that is string, and that is how we present strings in multiple ways. So the next thing we're going to look at is ints. So we're going to present ints. So let's come here, talk about ints or integers. So int Python is also very important data type that we can use it in different instances and different occasions, and it actually can use to um, literally represent numbers which might not necessarily require um, decimal numbers and all of that. So that is actually what we use int for. So it means we can just represent an int here. So we can use a variable to represent an int, or we can use a simple word or a simple keyword to represent an int. So we can also use um, we can use it numbers in this instance. So here we can say let's say num equals maybe 10. So this here is actually an integer, and this integer we can actually um, multiply with different integers. So we can say num2 equals 20. All right, so we can just come here and say print num plus num2. All right, so it means what we're doing is we're asking um, Python to print these two values by making reference to the different uh, um, variable names you've given onto them. So if you print this, seeing that it's going to print 30, so it's actually going to print all the other stuff for us. So it's going to print this ones and this ones for us. So let's just comment this ones out. Just comment them out so that we can actually avoid them as we work on this one. All right, so yeah, okay, so just comment those out. So now if you print it, it's actually going to be only for this one. So let me just clear this. All right, then we can have free space, so we can just run this to have. So it means it does that. The same way we can also change the parameters in the operators in here, so we can make it minus and still going to print out the value for us. So it means it does that. We can also use asterisk for multiplication. So this is what we use for multiplication in Python, and we can also print that. See that it multiplies that for us as well, and we can also use divide. So like that, and it's also going to do it for us as such. So that is simple int. So if we should add something like maybe uh, 0.0, now this value, let's see what we get if we should do that. Because that as soon as we actually add this, it means we are literally talking about a float. So we can have, let's say, this here minus that. Now, this is a float, even though it's a small value, we can still use an int. But literally, if you're talking about float, we're talking about this number in that instance. So we can have maybe 5.9. This automatically becomes a float. So it means we can make reference to this in the as a float. All right. So this is what makes integer different. So it means we can represent different numbers with integers with the value. So integer has an amount of value it can take, or and the same as for complex and all that. So let's quickly introduce float here as well. So float means we are talking about numbers like maybe um, let's say x equals 28.54. All right, and we can also say b equals 1.2. All right, so this becomes float. So we could, if you want to print this, we can just say x plus b. All right, so we can print this value. All right, so it prints this for us, and this is actually, so if you should bring something here like maybe a type. So what we're trying to do is when we run this, we're trying to ask Python what type of data we have here that's trying to print for us. So you see that it tells us this is class float. So it tells us that this is a float that we actually have in here. We should rather bring here num1 minus num2. You can see that it's also going to print for us that this is int. So we do that. See that it prints. Okay, so we actually have a float in here, so you see that that's that. But if you should get that out, and it tells us this is a type int, class int. So that is to tell us exactly what type of values we have here. It's going to actually print that for us in that order. So this is how we actually deal with float and int in that order. So then there's also a lot of ways by which we can represent float, int, and all that. So there's also option for us where we can also convert our float to strings and our strings to float. That is also an easy way to go by. To if supposedly if you want this here, let's say that you want to convert these values into int. What we can do is we can bring int here, all right, to show that this value we're trying to write, we want to actually represent it as an int. So you know that this x is actually supposed to, we are trying to represent as an int, and we are supposed to try to represent this one uh, as an int. All right. So it means now if we come here and we put a plus b, x plus b, now if we should run this, see that it gives us that this is class int because we actually put an int here. It tells that we are trying to convert this value into an int. So now if you add it directly, if you take this type out, if you add it, it's going to give us an int. And you can see that when we added it, it actually gives us an int value, right? Because now it actually ignores this decimal hidden value after the point, and it adds it direct. So it adds 1 plus 29, you see we get 30. So that is how it is. And we can, the same way we can also do it vice versa. So like we can also put a float here. So we can also make this float, and we can actually represent it to tell it actually, yeah, we want to convert this into a float, and we can also convert this one as well. Alright, so now if you come here, you should print now. If you should bring a type here, and if you make this num2 minus num1, and if you should print this out, you see that it's going to tell us that it's a type float. Alright, so now it shows us this is a float, not an int anymore. And if you should actually work this out, see that it's going to give us a float at the end of the day. So if you do this, let's see what it does for us. It's going to give us a float. Alright, so now it gives us a float. Alright, even though the actual numbers was 10 and 20, so it still gives us 10.0 float. So that is how you can also convert int into float and float into int in that order. Right, so that is how variables are in this instance. So since that we worked on floats, we worked on that. So complex numbers, we're actually talking about, if you say complex, I mean, if you're talking about numbers where maybe we might also add a bit of probably some letters or something. So we can have something like, let's say, say a equals, let's say 1.5j, like this is an example of a complex number in this instance. So yes, in Excel, this could be an example for a complex. So means that what we're talking about is this is actually a number, but it also has a bit of alphabet behind, right? So this is a instance of so if you should print this out, like let's say you should say um, type, right? So you should print this type. So let me put this here in comment. So let me clear this here. All right, so we can print this. See that it gives us a type complex, right? So it tells us that this is an example of a complex value. So that is how the different data types that we have in Python, right? So the next thing is to look at the list. So for list, we say that list can actually store multiple values, and there's a lot of things you can do with list. So let's come here and look at list. Okay, so list, let's give it a variable like maybe my new list. All right, so let me this. So this new list, it means if I'm going to write a list, so because this is a two variable name, so it means the next one must start with capital, and this I'm just adding an extra layer, but I can just have this. All right, this is also a variable, but whenever we're writing two words, it means the next one must come with capital. The two variable, the two words to form a variable. The next one must start with capital. Yeah. So this means I can use this bracket here to create a list. It means that anything I put in here is a list, so I can have um, ginger. I don't know how that came into mind though, but ginger. I can have carrot. All right. I can have kiwi. All right. So these are actually list, and this is how we actually define list. So it means installed it uses to store multiple data types in there. And so if we should come here and we should come and print my new. All right, so it means now I can actually, I should run this, I can see that it shows us, show me the list, ginger, carrot, kiwi right here. All right, so this one is still printing out. So let me comment this one out. Okay, so that is how easy it is. So seeing that list is actually ordered, and when we say that list is ordered, it means that the items have defined order and that the order will not change. And so it means that if we want to find out about this is in an index of 0, this is an index of 1, this is an index of 2. All right, so in what it does is whenever the computer understands this to the first one to be 0 and 1 the next one and as such. So this is an index, then this index will not change. So if you add new items to the list, the new items will be placed at the end of the list to add up to the index, right? And it's changeable, so we can change it. We can list is changeable, meaning that you can change, add, remove items at any point in time, and it also allows duplicate, so we can have kiwi and another kiwi here. List allows that, means it's just going to assign different index to this kiwi, and this kiwi is going to be different from this kiwi with index represented. All right, so that is how it is with representing a list. So if we want to count the number of lists we have, or we just want to try the function, we can determine how many lists we have by using something like length. So we can use the length. So this here will help us to know how many we have. So we should print this here. See that it shows us we have 4. So we have 1, 2, 3, 4 lists. So it prints to us how many lists we have in there. All right. So that is how it is working with lists. And the good thing is list can take up different data types. So list can be of any data types. It can be numbers, it can be strings, it can be booleans. List can take all of that. So it means we can have another list here to be maybe new list. This new list could be numbers. All right. This could be 1, 2, 3, 4, 5, 6. All right. This also list in this instance. All right. It's just like you can also take up boolean. So this is how list is represented. List can also take up different data types in line. So different. All right. So this different. We can have something like maybe 1, 2, 3. Then we can have A and B. All right. All right. And we can also have true boolean in this instance. We can also have 40.0 float in that order. So lists can actually take up different data types. So you see that we have numbers, we have int, we have string, we have boolean, we have float in there, and that is those are all how what list can do. It can take up different data types in that order. So if I want to see if I want to check which type of data, if I should add here type, it's going to show me that this is actually a list. So if you should run this, you can see that it shows us that it's a list. Alright, so you see that it shows us as a list, and that is how you can actually represent the list. So list is actually one of the way of storing data that you will be using multiple times as you write different programs, and you love to use it because it's very easy to use. And so that is one cool data types in Python that you love to use. Alright, so as we said earlier, list is a collection which is ordered, changeable, means you can change it, you can add some stuff, you can take some stuff out, and also allows duplicate. Unlike tuple, which is a collection which is ordered, unchangeable, and allows duplicate members. Set, on the other hand, is unordered, unchangeable, and unindexed, so you can't duplicate any member as well. And there's also the other part, the dictionary, which is a collection which is ordered, changeable, but no duplicate members. So you can see that you can do everything with list, but you can't do the same with the other data types, right? All right. So that is how cool it is using lists. So let's look at the different ways of using lists. So if you want to add access list, so if let's say I want to access this list, all right. So what we can do is, if you want to access the first list, we can, let me take this one out. So let's say if we want to access the first list, which is this ginger, or let's say it means we can bring this here, then we can put in 0. So now, because I can access only that part. So if I should print it, seeing that it prints only ginger for me. Alright, if we change it to maybe like 2 or 3 in that instance, so it's going to now print kiwi, which is this kiwi. So we're seeing that this kiwi is from that kiwi. So if I should put in 4, it's going to actually print the next kiwi for me. Alright. Okay, yeah. So it's 4. This is this one is actually 0. So if I should put in 2 rather, then it's going to print the next Q. Yeah. All right. So you see that printing next Q. Yes. So that is how I can actually access them, and I can also use minus or to actually do this. So by using minus, so negative index means that you're starting from the end. So maybe I can do -2 like this. It means I'm starting from the end. And if it does, it means it's going to pick up the last keyword for me in that order. So let's say if I have a different thing here, like let's say mango, right? So we should put in here that. So you see that it actually picks kiwi for me again, because that is the second one. So if I should put here 1, it's also going to pick up the last value for me, which is mango in that order, negative, right? So that is ways by which you can manipulate or access it. We can also have it in range, like maybe you can have it um, maybe 2, or let's say 1 through to 3, all right? So that is what we want. So now if we come here, you can make reference to it. See now it's going to print all numbers that falls between 1 and 3. So this is 1, this is 3 because this is 0. All right, so it's going to print that for me in that range. All right, so that is how we can actually go by list, and how we can also add items to list. So to be able to add items to list, it means that we need to introduce append. So let me take this one out so that we can see the one we're actually dealing with. So to be able to add that, it means we need to come here and then say new. So my new, sorry, so it means this, I'm going to bring the variable name, and I'm going to add here append. So this, then I can say that maybe I want to add orange. All right, so and I'll come here and add orange. All right, so now if I should run this, now let me take this one out. If I should run this, it's going to see that it's going to add up. It's going to add orange for me, so you can see they have ginger, carrot, kiwi, mango, orange. All right, okay, so you can also add multiple, so I can also add another, like what comes into mind, banana. Alright, so I should print this. You see that it also going to add both. So now it adds, um, yeah, okay, so actually, oh, yes, so actually it takes one argument, and I'm giving it 2 arguments. So append actually takes 1 argument, right? So I can only add 1 at a time. So I can add banana at a time. I can add both. So that is how it is. So you can see that now it adds banana instead of, and that is how it is. So then I can also insert. So the insert is item specific. So it means if I want to insert, it means that I'll need to be specific at where I want to insert it. So maybe if I want to insert this banana at the maybe on the second, means I want to put it on the second index. So means if I put the number here, it tells where I want to put. So this is 1 0 1 2. This is, so I want to put it on by the second index. So it means here I'm going to insert. So the insert item will help me to be specific, put it at specific index, and the method will help me to put it specifically where I want to put it by indicating the index here. All right. So now if I should come here and I should write Python 5. So you see that it says okay, I still have append here. So I have to come and put in here insert. All right. So it means I put that insert, and insert I'll be able to now add it there. So now I can come here and let me clear this. All right. And just put here, seeing that it actually insert the banana right after, right before the second value. So it brings it at the second index. All right, the same. So if I should bring it, should make it 1, and as such, you can see that it's going to actually put it at right by before the first what we have here. So you see the banana is right here now. All right, so that is how we can also add and insert into our user list. We can insert different. So that is how different ways we can manipulate list, and we can also extend the list. So to extend, it means we can just take, you can just bring extend here. So we can say extend, right? So with extend, it means that I can take that index out and I can tell what should I extend. So literally what we do with extend is that it means I'm going to extend this list, so I can come here and make reference to what I want to extend right in here. All right, so it means I can have another data type, like let's say my list. Okay, my list, and this is going to be, let's say let's say carrot. Oh, I already have carrot, so orange. All right. Okay, I can also have guava. All right. So now if I come here, I'll come and make reference to this, my list here. I'm going to extend it. So I'm going to have my list. I'm going to add this list to this list. That is how I use extend. So it means I can just have two different lists and just combine to have one list. And I'll use extend to do that. So now if I come here and I run Python on Py, you can see that it has added this list, orange and guava, to the main list. So now we have one list. So that is how multiple ways by which you can manipulate lists. So you see that there's a lot we can do with list, and that is one of the um, cool data types that you love to use as you go on and write various code. So you can see that we are going to talk a lot about list. We're going to use them multiple times in our Python program. All right. So that is how cool Python is, and you see that it's very easy to use, and a few lines of code you're able to do a lot of things with Python. So that is how it is. So on our next video, we're actually going to continue and talk about the we're going to talk about tuples. We're going to talk about range, dictionary set, and all the things. We're going to see how easy it is working with those as well. And so see you on this video, and keep learning, keep adding more value, and keep practicing. And I tell you, you're going to be good at Python in short time. Bye for now.